In terms of the aluminum that are used in the TS conductor, let me comment on whether there are work hardenings associated with it or to what extent that we may have some work hardenings. Our manufacturing process involves melting of the aluminum from aluminum rod, and the aluminum rod are pre-cleaned before they go into this melting process. And then we basically extrude aluminum out to minimize work hardening. And when we do, for example, the aluminum encapsulation process, there might be a very slight degree of work hardening because we do pretensions on the core and the aluminum will be subject to a very, very small amount of work hardenings. But the composite core is preventing that aluminum from being work hardened like a stretched. So that's very limited. And we also use a very conservative approach in terms of electrical conductivity. Because when you do work hardening, you do suppress your electrical conductivity of the aluminums. So for example, our encapsulation aluminum, we only apply 62.5% to guarantee that we are always giving our utility customers more conductivity than it might have. On the aluminum strands, we use similar process. We don't do wire drawing the traditional way, which require a lot of lubricants. We actually melt the aluminum, and it's an extrusion process as well, and it can be easily changed in terms of the aluminum strand shape, size, because the die can be switched out and remade in a matter of days instead of months in terms of the die manufacturing process for wire drawing. So the aluminum strand that's made out of our process has no lubricants in it. So it's clean in the entire manufacturing process. And then we go to the stranding process. During stranding, there will always be some work hardening because there is a bit of tension applied when we do stranding. So there's a slight amount of work hardening in there. The resulting conductor, however, of our aluminum, we always have conductivities guaranteed at 63% or better. Oftentimes we get to 63.5%, but we use 63% as a conservative number to provide that electrical conductivity for our utility customers. That little bit of work hardening actually is beneficial because when you work with fittings, like you do crimpings, especially forward press, our conductor, based on Lyman's comment, is less likely to birdcage because there's a little bit of that work hardening. And the typical ACSS, which also has annealed aluminum, these aluminums are often what we call dead annealed because they were put in the oven after the conductor is made. And so it is really annealed completely. So they're very soft and they're more prone to birdcage in the field. So there is that benefit with TS conductor in terms of that very slight work hardening, but we still give you that 63% or better electrical conductivity from the TS conductor. And it is a clean service that you will never have to worry about lubricants that goes through the service that may create a hydrophobic service, and it could create corona issues if you are operating at EHV and UHV applications.